Today we'll discuss about JEE Mains 2016 paper Physics. Students, let us solve the next question, question number 12. The region between two concentric spheres of radii A and B, these are the two concentric spheres, respectively, as shown in figure, has volume, charge density rho equals to A by R. This means that the charge varies from this point to this point. The density of charge varies. It is not constant. So charge is not uniformly distributed between this A to B in this region. Okay, where A is a constant and R is the distance from the center. R is the distance from the center. So I have this R equals to A and R equals to B. It is the minimum radius and this is the maximum radius. The charge is basically distributed in this region. Okay. So in this region the charge is distributed. Now the question is, at the center of the spheres there is a point charge Q. So at the center of the sphere there is a point charge Q. The value of A such that the electric field in the region between the spheres will be constant is. That means what value of A you should choose here, find the value of this A for which the electric field inside is constant. As we move from A here to here, everywhere the electric field is constant or same. So that means you have to find the general expression for electric field at any point here, and in that electric field expression you substitute that small r equals to A and small r equals to B and then equate that, because if the electric field is same, then electric field is same at here and here and here also. So we have two boundary conditions. We know that electric field at A and electric field at B, that will find it and equate it to get the value of this capital A. Now to start with, what you should do is, first of all, we'll consider a sphere. This is a concentric sphere. I will consider one more sphere here. So basically this is having radius A, this is having radius A, and this is having radius B. This is small sphere, radius A, this is B. Here this portion is only filled with charges, and at the center there is one more charge, is point charge is kept here, Q. So I have to, suppose I consider point P inside it at a distance R from the center of the sphere. So I want to find the electric field at this point P. The electric field at point P can be found by using Gauss theorem. If I use Gauss theorem, so E at P, electric field at P, can be found by using Kaas theorem. Now to use Gauss theorem, you have to, or to apply Gauss theorem at this point, I have to consider Gaussian surface. So I'll consider a Gaussian surface like this. So this is the Gaussian surface, and how much charge is enclosed within this Gaussian surface, if I apply Gauss theorem to this Gaussian surface, then it is E dot ds equals to integration E dot ds equals to net charge enclosed divided by epsilon naught. This is the Kaas theorem. Now this E dot ds, the total net charge is a combination of the charge which is present at the center, that is Q. This is point charge, and within this Gaussian surface, one point charge is already present, and another some charges will be included in this surface within these boundaries from here to here. In this boundary, we must have certain charges enclosed, because from here to here in this particular region we have charge density A by rho. So therefore, this region might include some charge. So how much is the charge which is enclosed within that due to the volume charge density? So I say, suppose that that charge is Q dash, then this becomes this by this. What is Q dash? Q dash is the charge due to which is enclosed within the Gaussian surface, and which is due to which is enclosed here in the concentric spheres, excluding this value within that portions. Now here the electric field will be radial outward anywhere, whichever is the, it will be radial outward. So the angle between E and ds vector will be same, is 0 degree, so it will be EDS. And what is ds? ds we have to integrate from this whole surface area, total surface area, which is 4 pi r square, because I have gone to a distance r to have this Gaussian surface. So this E 4 pi e square, 4 pi r square equals to this total value. Q is the charge enclosed plus Q dash divided by epsilon naught. So this is equation number 1. Now Q charge is present, that is okay, but Q dash charge is how much, that we have to find. To find how much is the Q dash charge, we have to, because this is charge density, volume charge density is sigma, rho is A by R. That means as you R increases, this will decrease. So as we move from here to here, the density will decrease, the density of charge will decrease. So it's variable charge density. How to find how much charge is enclosed within this? So first of all, we have to consider uh, from here R, we'll consider one through a small distance dr, we'll consider a strip. This is the strip I'll consider. So this is basically r dr. So this strip is the thickness of the hollow sphere or cell that I'm creating as a Gaussian surface. This is Gaussian sphere, hollow sphere, but then it has thickness. That thickness I consider as dr. So here to here it is r, then here it is dr. So if I bring this here and see how much volume of this sphere, then the volume of this hollow sphere, obviously Gaussian sphere is the radius is 4 pi r square and its thickness is dr. So this is the volume. Now if this is the volume, then what is charge enclosed? Charge enclosed by this volume of hollow sphere. How much charge it encloses is given by the charge density into the volume. The charge density is A by R and the volume is 4 pi R square dr. Okay, so this is A by R and this is 4 pi R square dr. So R cancels out and this is 4 pi A dr. 4 pi a dr, 1 r will cancel out, 4 pi a dr, 4 pi a r dr, so 1 r is left, 4 pi a r dr, 4 pi a r dr. So this is the small amount of volume. I will consider this as small amount of charge that is present here. So this is the volume I have considered. This is a charge. Okay, this is a charge that is present, but then this is the charge present. This is charge enclosed, charge for volume. This is charge enclosed by that small strip of. So within that strip of from R to dr, this portion encloses this much of charge. So this is I call dq, no problem with that. Dq charge is enclosed within this space, this part. But I have to consider how much charge is placed within that Gaussian surface. Then I have to integrate that. The q dash that I have represented. Q dash is the charge within the Gaussian sphere. Excluding the point charge is given by, I have to integrate this from 0 to a to r, because you can see here, from here the limit is a and I have to move to the distance r. So here this portion only includes these charges, so the integration will be from this point to this point, that is a is the lower limit and r is the upper limit, a to r, and then charge dq is 4 pi a r dr. So if I solve this, then how much is the q dash? Q dash becomes 4 pi a comes out, r dr integration is r square by 2. I have to use the limit from a to r. Then this becomes a to r. This is r square by 2. Okay, r square by 2. So this is 2 pi a. Okay, 2 pi a, and this is r square. So it is again r square minus a square. R square minus a square. This is the charge q dash. Now the total charge is now q plus q dash, which is q plus 2 pi a r square minus a square. Now I have to write the Kaas theorem, 4e into 4 pi r square. That flux that comes out equals to the total charge, that is q plus 2 pi a r square minus a square divided by the epsilon naught. So from here I write E equals to q upon 4 pi epsilon naught r square separately plus 2 pi a r square minus a square divided by 4 pi that r square and epsilon naught, 4 pi r square epsilon naught. This is my E, and if I rewrite that, and this is q divided by 4 pi epsilon naught r square plus 2 pi will cancel, the 2 is left out, so a into r square minus a square divided by 2 and r square and epsilon naught. Okay, so now this is the general expression this is the general expression for electric field at any point as a function of r, as a function of small r. Now I will put r equals to a to get the electric field at the bottom of the sphere. So then electric field at a equals to q upon 4 pi epsilon naught a square plus a into r square. R square is a square minus a square divided by 2 a square epsilon naught. This becomes, if I solve that, okay, this is 0, so this is q divided by 4 pi epsilon naught a square. This is electric field at a. At a means electric field at a means at this point the electric field is this one. Similarly, I will find electric field at b point here when the radius is b. Then what I will have? This is one equation. I will equate electric field at a, electric field at b. So electric field at b, r equals to b. I put here r. I put as a. This is q upon 4 pi epsilon naught b square plus a into b square minus a square divided by 2b square epsilon naught. So this value and r equals to a, this value, r equal to b, this value, according to the quotient that the electric field at everywhere inside is same. That means this and this must be equal. According to quotient, EA is EB. Then what role that A plays here? EA comes out to be Q divided by 4 pi epsilon naught A square. Okay, just I'm rewriting those equations. EA is this and EB is this. Okay, and equating it. Q divided by 4 pi epsilon naught B square plus A divided by 2B square epsilon naught B square minus A square. So from here I will cancel epsilon naught, and this is brought to this side, and therefore this q upon 4 pi being common, I will write 1 upon a square minus 1 upon b square, because a square is there, b square is there, this comes to that side becomes negative, and here I have a divided by 2b square, b square minus a square. If I take the LCM over here, q divided by 4 pi b square minus a square divided by a square b square equals to a divided by 2b square b square minus a square. If I use that, then I can cancel b square minus a square both sides of this equation. 2 I will cancel, the 2 remains here. Then I will rearrange the equations to get what? Let us see here. Q divided by pi and a square b square down there. Then this b square will also cancel out. You can see here that b square will also cancel out. Okay, this b square will also cancel out. So I will cancel out the b square, or bring to this side and cancel out, and that equals to a. That's all. Okay, that is there, and 2q upon 2 pi, 2 is there, 2 pi, q upon 2 pi a square equals to a divided by nothing. So from here I am getting a equals to q divided by 2 pi a square. if I see the option, here I see the option, then you can see that option number 1 is correct, q upon 2 pi square, q upon 2 pi square. You can see that this is the value of A for which the electric field has to be constant. So this value of A gives you E equals to constant. In between the radius A to the radius B, everywhere electric field is constant. Therefore, the option number 1, option 1 is correct. Okay, thank you.